So you can go to 400 Pascal for this system. Variable pressure mode. I mean, I wrote a sample called the paper sample. So it's non-conductive. You need to change the aperture over here. You need to change to the
750.
The larger.
750.
Yeah, 750. I kind of not that exactly the aperture position. Can I write down the? You better to write down the current position, the Y lah. The Y now is 6.1. Yeah. The 300 is let me look at that. It's about 9. Yep. Yeah. You have to remember, otherwise you don't see anything, because the small aperture and the two small aperture, they can't really align it. Here we go. It's about 9 or 9.1. Yeah, but you don't really need to care too much about that. You just see it right. That's all. It's about around 9. So for variable pressure mode, because I'm going to say Because now the whole vacuum is very low. You see here is about 80 Pascal. So compared to the one we are doing just now, there is -5 millibar. So there are so many gas molecules. There is 4 around inside the vacuum. So this is the primary electron that Hill sample, and it generates the SE1 signal, which is very weak. They are very weak signal. So this is an SE detector that has the cage, so you can attract them and the beam detect. But now it's not high vacuum. There are so many molecules there. So there's no way this SC signal they pass through so long distance without interaction with the molecules and be detected again. So that's why we come up with this new design called the variable pressure SC detector. Although it's called the SC detector, but it's actually not detect the secondary electron. Rather than that, it's actually detect the photon. When the SC signal is interact with these molecules, you will lose energy and you will come out with some photon. And those photons then can be detected by the variable pressure SC detector. So you need to know that. So in the variable pressure mode, this SC detector cannot use. You have to go to variable pressure SC detector, but the backscatter detector is still able to use. Because the backscatter detector are detecting the high energy SC backscatter electron, so they are still okay. And and another thing that because the system is in a very low vacuum, so many molecules, it not only affect the SC signal, but it also affects the primary electron. The primary electron initially want them to stay in focus, even leaving the column rack, want to stay in focus to reach a sample. But because of the molecules of there, so it may separate. The electrons will separate. We call that skirt effect, like a lady skirt. So that's why you need to have a shorter working distance to reduce this kind of skirt effect. And also you have to use a slightly larger EHT and the larger the probe current. That's why you go the GAT9. You see the long conductive sample, what they tell. For long conductive sample, go to variable pressure mode. It suggests you to have a reasonable larger probe current. And the working distance is very small. And 750 microaperture, we already adjust. And we place a 100 micrometer aperture. Using the backscatter detector or VPSC detector. All the chamber pressure is just to eliminate the charge. There's no real value for that, but you have to eliminate the charge. So you see I put 80. This value is not fixed. Sample to sample is different. But I go to the gun. I don't using such larger probe currents. I'm using 300 frequency.